Good evening. Sorry about that. Good evening, and thank you for joining us. I am pleased to welcome all of you to our first ever virtual event that we'll be holding about AI for fashion and retail industry. My name is Kahin Akram, and I will be the moderator of the evening today. And if you have not heard of us before, we are Norrköping Data Science Community, consisting of me, Nils, and Allan, who are behind the camera. So, hello, Allan.
Hi, everyone.
And our goal is to educate as many as possible on how data is used and how it is to improve our societies and so on. But before we start, I would like to thank Norrköping Science Park for being a support for a really long time since we started for hosting these events and setting up all this streaming equipment. And what AI has done is it has changed many industries, and especially in the fashion industry, where it has played a crucial role in changing a lot of key divisions, such as the design, the logistics, the marketing, and all the way to predicting trends in fashion. Lately, e-commerce has also shifted a lot of industries from being physical stores to more user-friendly spaces where the companies can track the customers' activities more than ever done before in order to improve their user experience. And tonight we have with us two companies who are working with doing this type of AI implementations to improve certain industries and especially the fashion industry. So our speakers will first present, and unfortunately one of the speakers could not be here physically with us, and he will be joining us via Zoom. So let's hope that everything works smoothly with that. So the first speaker is our first speaker, who is he's a developer, he's a scientist, and a research leader with over 2 decades of experience in academia, private and governmental sector. Currently, he is a board member of 2 expanding companies and 2 startups. He has over 50 scientific publications and 6 patents granted, with more in the pipeline. His interests include computer vision for face tracking and analysis, infrared and hyperspectral systems for automatic detection, for monitoring, and today he will be sharing with us a bit about computer vision and face tracking as its finest. With that, I ask you to give your full attention to Dr. Jörgen Ahlberg and help me welcoming to the stage. Doctor?
Thank you. So I have some slides, and let's see if they will come up there. Yes, they do. So my name is Jörgen Ahlberg, and I am representing the company Visage Technologies. And I will talk a bit about the company, what we do, and then how this relates to fashion and retail, and then a bit more technical of how some of these things work for people who are interested in the inner workings of AI, in a bit of a historical context as well, since, well, I'm getting old. So, computer vision at its finest. It's a company now with 2 offices, 90 people. We're divided in 2 divisions, face technology and the automotive technology. Automotive, cars and things like that, that is not really fashion in detail, so today I will talk about the face technology stuff. We started in 2002 in Linköping, right a few kilometers in that direction. We eventually also started an office in Zagreb, since one of the founders moved there. And thanks to a very nice collaboration with a university in Zagreb, we have then expanded there as well. So we have most of our engineers there nowadays. We started with face animation, but then it turned out the face tracking was more business. And then the automotive division is a bit newer, but by now actually the larger one. It was started, as I said, here in Linköping by these guys, and then Marco joined a bit later. As you can see, this is quite an academic bunch. We knew actually nothing about business. It's a bit fun nowadays to look back, and I'm still a bit naive regarding business, but well, I've been more naive. What we do, we have this product, Visage SDK, with the components face track, face analysis, and face recognition. Built on these things, we make solutions for our customers, like virtual makeup, eyewear try-on, liveness detection, and we also do custom development for helping our customers, well, maybe modifying the things we have, or integrate it in their products, or maybe even build quite large part of the products. So this product, the Visage SDK, well, it contains algorithms for finding and tracking face and facial motion, gaze direction, and also for doing analysis of the face. So like, how old is this person? Is this a man or a woman? Does this person look happy or sad, and so on? And we deliver this platform on a range of platforms so that it can be used on, well, machines like this, and also mobile phones, built-in embedded systems, and even run in a web browser. So the input, images from any kind of camera or image source, and then we get a lot of information about the face. I will show those things a bit. So the first component, face track, to detect where a face is, to detect these feature points, to track them in real time in video, including the eyes, so we can see where the person looks. Face analysis, so as input from the face track module, we see where the face is, and then we can put this into our neural networks and get out then, for example, in this case, a female, age 23, with a quite high score on surprise. And face recognition, which is maybe the most hot discussion topic nowadays, to verify or identify a person. Okay, that's John Miller. So today the topic was about fashion and retail, and then how do we apply this to fashion. Our application field, beauty or fashion and beauty, it of course has also face-related things in there. So it could, for example, be like this. Let's see if this video actually works. Where we do face tracking for artificial intelligence, AR and VR, improving the makeup. I don't know if it's really visible through the camera here. Trying on glasses virtually, trying on jewelry. See how you would look in that, color lenses, or various AR masks have been popular the last years, and to do other face modifications in shape, color, size, or whatever, or actually use this motion information to control avatars. So to do all of these things, the first step is to localize the face and find all the points in the face and how they move so that you can modify the image accordingly. The second trick is, of course, to modify the image in the right way, like adding lipstick and so on with the right colors, the light, the right lighting, etc. So our applications then, virtual makeup try-on. For example, in the mobile phone app, you can then see how would I look with that makeup or whatever. Doesn't go very well with my beard, I must admit. Looks a bit scary. An example of from our customers there is Oriflame's virtual makeup try-on. Hair color try-on. You can sit down when you go to get your hair colored and actually see in the mirror how would I look in this hair color or this one, and you can tune in the color, and then when you've decided, you can actually get your real hair colored in that way. For example, Peak digital smart mirrors for hair salons. Smile try-on. Yes, actually, if you have gotten your teeth destroyed, you can go to the dentist and see, okay, if we reconstruct the teeth this way, how will I look? And various accessories like glasses and headphones. And, well, there are a long list of applications where you can use this in the fashion and beauty industry. Then again, this was about AI, and the AI here is actually not for our part, it's not about shopping behaviors or things like that. It's about analyzing the faces, and the major trick is to actually do the face mask alignment to find these points in the images and the 3D pose of the head and face. And I've been working with that for quite a few years. This is me 20 years ago, while I was a PhD student, working on what was certainly not called AI by then, but it's been a bit broadened. Now it works. Well, nowadays it actually works. I would be very happy to say that it was thanks to me, but I've been out of the code now for a few years, and I have younger colleagues who are doing things that I couldn't even imagine those days, and well, sometimes hardly nowadays. This was how it was done 20 years ago. Had an image of me, and then I had some erroneous image. This is not the right way to put the face mask. We normalize it in geometry and make a reconstruction and see that, oh, there's a big difference between these. We should modify the face mask. Some of these things actually have bearings on how it's done today as well. One large difference is that I use images of size like 40 by 40 or 80 by 80. And I had a huge database of face images. I had 50 images. And nowadays, you can't do anything with 50 images. So how is it done? Well, it's a lot about regression. You have a suggested set of feature points, a face position and so on, and you try to improve it. And until a few years ago, this was done with handcrafted features. That is, you had your machine learning algorithm to learn how to tweak the face shape, the face position, or the feature point positions. But the image features, they were still handcrafted, something that a human had invented. One thing that was made the progress happen was that you have cascading regression. We do this in steps, and also with shape index featured. That is, instead of having everything in a coordinate system centered on the face, we have separate coordinate system and separate feature sets for for the different facial features. And for each of these, we could have some machine learning algorithm, for example, a decision tree. Decision tree is very simple and efficient, where you basically check features and see that maybe just pixel values. Oh, if that one is brighter than that one, go here, and eventually end up, oh, I should move my feature 11 pixels to the right and 5 pixels down. And then you narrow in more and more by doing this cascade of regressions. So for example, here you would compare pixel features. We see over here from the beginning, I should move there, and then I move there. I search in a smaller and smaller window, and I end up at the correct point. You do that for a lot of points in the same time. You see, maybe you see at least a face mask there, and see how it adapts stepwise by moving the feature points closer and closer to the real target. This is probably easier to see through the video. You have some face shape, and you gradually, step by step, adapt it until it fits the face. Yeah, I said those things about simple and handcrafted features, and if you're going to do this in video rate, you really need to make the things fast. Some neural networks are large, they take a lot of computational power, and depending on your requirements on hardware and speed, you might prefer to do things not only with deep neural networks. So for example, to train these decision trees that I mentioned, and what you typically would do then is you train a bunch of them, a forest. And then you actually train them, and when you run them, instead of finding these numbers below that I showed, oh, move 11 pixels there and 5 pixels there, when you do that for all of these trees, but you only check where in the tree they end up, and you get it long sparse vectors with a few ones, but mostly zeros. Then you do that for each of the facial features. You get this long vector, and you concatenate them to a really long vector. And then you train a regression matrix on that, where you have a linear projection in the end. The good thing about this is that it becomes extremely fast. Since the only thing you need to do is to just make all these tiny features, you run them through your decision forest, which is very quickly done, and then it's a sparse matrix multiplication. So this is much faster than most neural networks. Then you can have this regression here, and then it becomes much smaller, and you can have a neural network in the end. And then it's really, the neural network is really small. So local binary features to start with, and then add to that a neural network. And we do have a publication about that. One of my colleagues who did this work. And then a bunch of different methods like this you can find in the literature. Deep learning then. Everyone talks about deep learning in the last, what is now, 5 years? And well, that's used for faces as well, in a set of different ways to have these good old-fashioned 3D morphable models. And you have a cascade of convolution neural networks updating the face model until it matches the image. There are also people working on multitask learning, where you train a network to actually do several tasks, not only to adapt the face model, but also check, oh, is this guy wearing glasses, smiling, extract the gender and pose. Because these things are correlated. It's easier to estimate the gender if you already have compensated for a smile, and etc. However, there seems to be no large difference, no large gain of actually doing multitask learning, and it's also might be a bit more tricky to get the training data. There are others, though, who rather do things in parallel, having parallel neural networks, doing the local regression and then composing it in the end. And also doing various coarse-to-fine solutions where you have a set of different networks working on different precision on the face. And what is probably, at least was a few months ago, state of the art was the deep alignment networks. Where again, you have a chain of different stages with neural networks that refines the results of the previous. People working with neural network nowadays, they often like to have end-to-end in their header of their presentation or their paper, because that's when you train everything from just the image and get out the end result, which sounds very nice, but it's often very difficult to accomplish in practice. And so far we haven't seen that much with faces. Another face-specific problem is the occlusion. How do we do when someone is like that, having a hand here or a mobile phone or whatever, or a baseball cap, or maybe too much beard? Well, you have to find a method to weight down and train your methods to see that, okay, now I can't really trust these feature points. This guy has a beard, you can't really see the contour here, etc. One way of doing that in the literature is to actually optimize a likely image without occlusions, and then run the alignment on that. And you do that again in the different various stages where you repeat the reconstruction, alignment. All AI, no, not all AI. AI is a big thing. Machine learning is a part of AI. All machine learning nowadays relies heavily on data. All these methods I've described, they require a lot of training data, and in this case it requires a lot of face images or videos where someone has manually marked all these points in the face, or for that matter, age, gender, etc. And there are, of course, databases available. We also do a lot of annotation by ourselves. Maybe not always the most fun work. And you can see, for example, annotated face, labeled faces in the wild, 26,000 images where 21 landmarks are pointed out. And many of these data sets also have quite a lot of errors. Some of them have landmarks with occlusions, so that they actually mark like this. The eye is probably here, but these feature points are occluded. So many face-related problems in AI is about having a lot of data and having good data. Another one of my colleagues made these tests about estimating age from images, and by having some other AI actually cleaning up the data, we got a much smaller set of data, but we still got better results. So quality of data is really, really important. I just wanted to show this. You don't care about the real contents, but you can see now in the literature there's so many different approaches to this. I mentioned just a few of them, and well, you see that where you can compare the performance, and each month there's something new. Basically, the most robust and accurate algorithm nowadays for analyzing faces, neural networks. If you want something that's really fast, go for some simpler features, tricks and techniques. Because the neural networks are comparatively slow, but then again, there are methods with simple features. So the tricks: shape index local features, go separately for face features and combine them. CNNs are very good for global initialization, convolutional neural networks. They're also best for accuracy, but simple features best for speed. Part-based fine-tuning seems to, with the different parts of the face, seems to be also a good approach, and you can always get more training data. I might, if time allows, during the panel also show a demo of this works in real time. And you're also very welcome to check that on our webpage. If you look at visagetechnologies.com, there is online demonstration where you can actually try out our tracking in the web browser, even without downloading any software. Thank you. And I hear the audience cheering. I wonder if there's someone there. Is there someone there?
Yeah. Fredrik, is my on? All right. Thank you very much for the interesting talk. And we will be talking a lot more during the panel discussion. And to swap presentations, we will be back in 1 minute. Welcome back. Our next talker is from Stockholm, and he has been a Swedish serial entrepreneur for the past 25 years. He co-founded Nomi, a Swedish company developing e-health systems based on unique AI. He lately co-founded Norna, an AI tech startup with the goal to collect big data regarding the colors, the shapes, and the textures people use in their clothings. Furthermore, he also co-founded the AI Hub, a network with the mission to support and stimulate AI entrepreneurs in Sweden. He is also one of the initiators of the Swedish industry code around AI, and today he will be sharing with us how AI is used to organize fashion products for improving decision making around and predicting fashion trends. So please give your full attention to Micheal Collaros and help me welcoming him to this virtual stage. Please, Michael.
Kahin, and thank you very much for inviting me to this event. I will talk a little bit about Norna, and I will give you like a short background of the company, also a little bit about the changes in the industry right now, and in the end, I will also show you a little bit about the technology we are using, especially the AI technology. As Kahin mentioned, my name is Micheal Collaros. I've been working in this space, I think since like 2014, I started my first project around this. And I always think that AI is super interesting technology. Around 2018, in the beginning of that year, it was like an old colleague. He showed me a very interesting AI model. It was about image processing, and the whole idea was that he did it with super high resolution. So we could see, for example, if we had an image, we could see it was a person, what kind of clothes they were wearing, the textures, everything. And for me, it's become so interesting. I thought maybe we can use this kind of technology just to collect a lot of product data and understand, big product portfolios. So we started a little bit from a tech point of view. And one of the idea or like the vision or the statement of the company very early on was to like organizing the fashion products of the world to improve decision. It means actually collect a lot of like external data and use that all this data so all these fashion players can really understand, how the market is changing, about the prices and all the assortments. So that was like the high level idea. As we all know right now, all these retailers, and especially in the fashion retailers, there's a lot of pressure right now. They have quite old business model. It's like, manufacturing clothes, shipping them to all the stores, and it's totally based on physical store today, or most of it anyway. But they try to change that, but there is like a big pressure around this to do this much better. And there is a couple of players that doing this very well right now. And two examples, of course, one is Amazon, and we know that they started in North America and they've moved to Europe right now, and they did like the premiere in Sweden like a week ago. So they coming here, and also in Asia we have Alibaba. The big difference between this like new kind of retail companies and the traditional business is like they are really tech company. They understand technology. They use it to actually win this battle. So it's a very difficult situation for all these new old school retailer, because this kind of players, they're really changing the market right now. In 2018, I got invited to Alibaba to discuss technologies. So I went over there and I met actually the AI lab. So in the headquarters of Alibaba, they have like a big team just working with artificial intelligence. and it's all about, it's about user experience, personalization, optimization. It's about logistics. They're doing a bunch of interesting stuff there. And one thing I saw what they were doing, they did so much analytics, internally using the internal data, but also external data. So they understood everything what the competitor did. And that gave me a lot of ideas. So one of the ideas for Norna was like, okay, the traditional retail industry, they can never do this. It's too complicated. But if Norna can develop this kind of technology, I think it was like a big window for Norna to do that in a better, smart way. So that was like a big insight that I got from the Alibaba team, that this could be something super interesting to and develop it for more like traditional retailers. This is more like a sidetrack. One insight that I also got from when I worked there in China was that 2018 it was like a lot of focus on computer vision, and of course, and that's also quite interesting that this kind of digital player, they started physical stores. So they came from the digital world and they start to do physical store. But of course, they use technology to do that. So this is an example on the headquarters of Alibaba. Here is a store. And you can see up in the roof here that there is like camera. So you can just take any product that you want and you just go out from the store. And in China, they have this super big database. So all Chinese have like a photograph from themselves. So Alibaba and of course the government can track everyone. Very scary, but that's the way they do it. And one thing that I also saw when I visit a lot of these Chinese AI companies is that I were a little bit interested in the funding of these startup companies, because if you're like a Swedish company, it's super hard to get funding. Either you go to Vinnova or the innovation system, or you go to investors. So in my case, I tried the innovation system. It's very slow. So right now we have private investors, but in China, all these AI companies. Here's one example. It's one of the bigger AI companies in China, and they're doing a system for self-driving cars. That's the big case. But they got a lot of funding for the government, and of course, it's about monitoring people. So they get all this money from the government, and they use it to do new technology also that they sell to the Western companies, to Europe and stuff like that. This is just a sidetrack. So it's quite interesting to understand that they got massive fundings from the government. So, of course, Alibaba and Amazon, they have it's a big impact on the market right now. For example, in China, Alibaba have 58% of the e-commerce, the total e-commerce market in China. And if you add also the sub-brands, because Alibaba owns other brands also, I think the numbers is up to 80% that they control. So they are a super big player in China. And if you compare that to Amazon, they also are like a really big player. They have 39% of the e-commerce market in US. And I think the numbers they have for some years ago that they went to Germany. I think they have the same numbers there. And that's why also I think a lot of companies here in the Nordic, they are super scared of a company that actually can take 30, 40, 50% of the total market. So they have a really big impact, these kind of companies. And one insight that I actually get from Alibaba, and also what Amazon is doing, they use something called dynamic pricing. Dynamic pricing means that they use a lot of data to understand, the internal flow on the site, but also the external flow of all the competitor. So they change the prices all the time. And that's quite interesting. One example, Amazon.com, they're changing the price 250 million times every day. And if you can compare that to a Swedish e-commerce site, they don't do that, especially in fashion. They do it twice a week. They change the price. So it's a different ballpark here. company that really, really understand the technology and how to use it and how to win. If you compare that, I've done like a lot of interviews here in Scandinavia and in Europe with a lot of retailers, and somehow my feeling is not all of them, but most of them work very traditional. And you can compare that a little bit to the financial market a little bit. You know, like 100 years ago, if you were like buying and selling stocks, it was like a market floor, and you try to find a buyer of your stocks on that market floor. You had no clue actually about the real market price because you don't had like the information around that. Somehow the retail industry, they don't really, you know, if they have a product, they have a feeling in the stomach, the price should be like this. Maybe they do some research, but not a lot. So they really, really work like in a very old school way. And here is an interview I did with it's a Danish fashion player. So I asked him, actually, how do you work with the prices? So if they do a shirt, for example, and they have a manufacturing cost of 50 kronor, and they do the manufacturing in Sri Lanka, and they take it back here to Scandinavia, and the out price will be like 250 crown for Swedish crown for that shirt. And if they don't sell after a couple of weeks, they do sales. That's, you know, so they have like a ladder for that. And after 5-6 weeks, if it's like a bad sales on that shirt, they do like a new sale. Then it's become like 50%. And after a while, it's 70%. And in the end of the day, in this case, this Danish company, they destroy the clothes. They don't want to sell it to outlets. Some companies, you know, ship it to outlet or try to give it away. But that's a little bit how they work. So that's why I think from our perspective, they should maybe look a little bit more at technology to understand the marketplace a little bit more. So I will give you some example how Norna is using the technology to help these retail fashion players. So what we actually do, we do a lot of scraping. So right now, I think we scrape all the big vendors in Europe, and every day we have 4 to 5 million products that we take into the system doing analytics on that. So if you're, example, H&M, you can very early on have full control what Zara or Uniqlo or the other fast fashion players are doing with the assortment. You can understand the prices. So you can understand the price history on all the competitors in real time. You can take all this information and put it in. They use something called price ladders to understand the structure of the price. And they do it, most of the company are doing it manually today, and we do it automatically, like in real time. You can understand all the markdowns. So if, for example, if you're H&M, you can understand that, oh, right now, Zara have a lot of sales, or they are out of stock of this kind of clothes, and you can do a reaction on that. So you can, you know, start to do some sort of optimization of your prices in real time. So that's a little bit what we are doing, what kind of a business value we're adding to all these customers. We have a product called Veriscope, and we're using that right now in Scandinavia. And in the spring, we will scale this out all around the world. So that's it's a lot of work, and we've been around 30 person working with this project now for almost 2 years. So as I mentioned, we're doing a lot of data collection, and we put that, of course, in a cloud service that we break down everything in different kind of properties, and we present that in a front end, what we call Veriscope. The AI we're using, and I just will give you one example how we're using artificial intelligence here. One important part is, for example, we have like tools like Price Runner or Prisjakt here in Sweden, so you can compare prices. It's quite easy. If you have, for example, one pair of Nike shoes, the Nike shoes have a product number, so it's quite easy to do like scrape the data and understand that there is like a lot of vendors selling these kind of Nike shoes. it becomes much more difficult if you're doing your own design, for example, like H&M, they're doing a shirt, it's a unique shirt, but you want to compare it to similar clothes, for example, what Zara is doing or Uniqlo or whatever you want to compare to, then you have to use some kind of AI to break down the product and compare it to competitors. So that in that case, we're using both image and text to do the comparison. In this breakdown process, we're using two different kind of technologies. We're working with natural language processing, which means that we do some analytics on the text to understand. And sometimes when it comes to fashion, it can be quite difficult to understand because in the text, it could be like, oh, this is a shirt that fits with this kind of trousers. So we have to understand in the text, it's a shirt, it's not trousers that we're looking at here. And we will also use like deep neural networks to understand the image. But the trick for us is a little bit because it's always difficult to do the training on the models. So we do like what we call like hybrid models. So we use the NLP to train, the CNN model and the CNN model to train the NLP. And it's a quite smart way to, what we think in a way, to train the model. Also worth to mention is that we very early on got a couple of very, very strong partnerships. So for example, we're working very tight together with IBM. IBM have something called Watson, and Watson is it's a brand actually. It's not a technology. It's a brand for their AI movement or the AI technologies. So when it comes to IBM, they are super strong when it's come to NLP part, but they are much weaker when it comes to doing some kind of analytics when it comes to images. So they find it very, very early on that we should do like some kind of partnership. So IBM have supported us a lot. So for example, they have give us hardware. They are building this like super server for super fast analytics on this kind of AI. So it's, if you have like smart technologies, there is always a possibility to get this kind of partnership, even with IBM or Google or Microsoft. They are very interested to do like this kind of partnership. So it's a really good insight to understand that there is a possibility to find this kind of partnership, and they can add a lot of resources on this. So that's quite interesting. I also want to show you a little bit. It's always very, very difficult to explain what you're doing a little bit. So I try to find a way to explain, even for the customers and people that working in the company, what we're actually doing. So I would show you here a little bit what we're doing. So hopefully you see my image here. So here, it's not a map. It's actually a model that I have here. This is actually, there is a vendor here in Europe called Zalando. So this is 300,000 products from Zalando, and we use this model for understanding pattern. So just by downloading all the products from Zalando, we can like clustering all their products in a very, very smart way to understand the assortment and also understand the price level on Zalando, for example. But the cool thing with this is actually here you can see it cluster all the red parts and all the blue parts. But what I think is super cool that, for example, something that's quite complicated to understand, it's, for example, animal patterns. So here can you see that the AI model have clustering all the, I think it's leopard. So it understands actually this kind of texturing. And if I go here a little bit on the side, you can see it changes a little bit. So it become, after a while, it becomes dots. And sorting out like 300,000 products, it's quite a big job. But when you're using this kind of model, it do it like super fast. So it's a very, very powerful way, to sorting products out, to understand it. And right now we're sorting product, we're using like, I think it's 1,600 different kind of properties, because that's why very, very important. If you are like a fashion retailer who really, really want to compare certain kind of properties to certain kind of, competitors, So that's one way. And I will also show you here. This is not a map either. It's actually, this is H&M, all the products that they have. So I'm sorting up, all the products that H&M have here. So if I go in here, you can see, for example, and in this vector space, I placed them. So it's about shape and colors. So you can see if I go in here, you can see, for example, that we're sorting, here it's like dresses, and here it's like shirts and the blue shirts. If we go here, down here, you can see that I understand really, okay, this is trousers. And in the end here, it's like, okay, and jeans, it's quite difficult with jeans. So we put the jeans here. And if you look at this big map, you can see that some products, it's quite strange. So they put them here. And here, for example, you can see, here's bras. And there is something different here. So here is glasses, for example. So this is a way just, to sorting things out. And I think the combination using like image analysis and text analysis is super important, or it's a very, very powerful tool to do that. And somehow it's a way for traditional retailers, to use technology to understand what Amazon is doing or what Alibaba is doing, because they are doing this by themselves. So this is just like an example how to use AI. So that's me. Thank you.
welcome back. Let's start directly right into the discussions. And of course, you're welcome to ask any questions in the chat, and we will try to answer as many as we can during the panel session. And it should take approximately 60 minutes to an hour. All right. Thank you very much for the really interesting talk, and thank you, Micheal. So I am interested in knowing when you first got to your first interaction with AI. When was it, and what made you decide to tackle the subject that you presented today? And this is a question for both of you. So why did you stay in this topic?
Oh, it's a bit contradictory for me, because I actually, when I made my undergrad studies, I had a course in AI, and I kind of decided that's something I will not work with. Okay. And then I went doing things that I thought were more interesting, and it turned out that turned out to be AI as well. But then I was kind of led into it another way.
And I know that feeling.
Yeah, and then I was working with it for many years without any of it was being called AI. And then I mean, I was working with image analysis, image processing, and then when it actually kind of merged with machine learning a few years ago, and it became really powerful. Which was pretty cool, actually, by then.
All right, so let's see what Micheal has to say. And what made you stay in this area that you are doing work in nowadays?
Now I started to look in this space. I think it was like around 2013 or 2014. I was working with sensor technology, and we get so much data. And to be honest, I think before 2015, it was like an area. It was super hard to get like funding for this, and it was like, for me, it was like when I talked, for example, with Vinnova or like to get this funding, everyone was so skeptical. And I think the big thing was like 2015 that Google started to talk about AI a lot. And then all the investors, started to have like, we must invest in AI. But I really had this idea from the beginning that AI will be, all the technologies under AI, they will be like internet, they will change a lot of things. And I think it's very easy, if you compare that a little bit to internet, everyone around 2000, everyone was, oh, now internet will now not change a lot of things. But, we see today, 20 years later, that it changed a lot, actually. And I think the AI, in 10 years, it will change everything. So I think it's a technology you must look at. And if you are a company and don't like look into this area, you will be destroyed or disappear.
And we have a question from the audience here, and Marcus is asking, it's really cool, these visualizations you're doing. Will it be available for the customers?
Is it for me or? The thing is actually, yes, I'm thinking actually, because right now we're doing like a business-to-business model, but of course, we can do like a super powerful price runner if you want that. So there is one idea that I have. Maybe we can do that. So yes.
Great, thank you. So you're welcome to ask any questions you want, and we will try to answer them. So if we move on to the next question, and this is for both of you again, how has the industry you're working in, it's a little bit different from you two, with the facial recognition and trend prediction and fashion, with the colors and shapes. How has the industry changed? What are the biggest changes since you started? And who are these other major companies doing similar things that are different from what you are doing?
Let me start with how it has changed, and it has made computer vision become useful. When I was a student, it was a very popular topic to study. It was a bit like science fiction, but you couldn't actually use it for much in real life. There were some industrial and medical applications, but the last years now, partly because of starting to use AI techniques, it's been useful like everywhere. Things have been so much more powerful. It's found so many more applications. So it's really been a game changer from being something which is cool, but it's for some special things only, to now it's everywhere.
Everybody's talking about it now.
Yeah, and it's used. I mean, it's really have practical use cases, which they were pretty rare.
Yeah, exactly. It feels a little bit like they are talking about it, but not many people understand what is going on behind the scenes, and that's what we are trying to do here, to educate. So, Micheal, how has the industry you are in changed?
I think for me, I totally agree, and I think what's happened for the last 2 years anyway, it's a lot of these business people in the company. They understand that they can use this type of technology to add some business value. Before that, my feeling was that it was mostly like tech people doing we were just like developing cool stuff. But my feeling is when, for example, in Norna right now, I think there is like a much deeper understanding, even with with the business people in the company, that they really understand the business value. So yeah, so I think it's the company is becoming more and more mature, so they understand how to use it.
So what do you think will happen in the next 5 to 10 years?
Oh wow, that's a difficult question. I think it's going to happen like a lot, and I think it's going to be like the companies around this kind of project. It's going to be much better, to organizing the production and development team. So I think that's an important part, for example. And of course, it's going to be a lot of new tools around this, based, on this kind of technology.
Interesting. Do you have a question for the area Micheal is in? Have you worked with something similar before?
Not really. I've been slightly involved in a project where it's about setting prices automatically on food in ordinary convenience stores by analyzing with cameras to see how much there is stock, if things are getting old, and that might happen in a few years.
So it did scan the shelf, and then it looked at how much it was left, and then
if the fruit are becoming old, for
okay.
example.
Oh, that's
It's not there yet.
It's not there yet, but it does exist, I guess.
Sort of. Almost.
Are you working with that as well? Or?
Yeah, maybe we will be involved in that as well. Yeah.
Micheal, do you think that could be a thing for you in trying to figure out how to price the products by looking at how old where the clothes is?
Yeah, I think that's quite interesting, actually. One problem I think a lot of retailers have, because they have one digital store and they have one physical store, and it's super complicated to understand the price in the physical store compared to to the digital world. So I know that there is a big need there. So I think that's super interesting.
Right. Thanks for that. So who are your competitors, if I may ask that question? Who else is doing advancement in this field?
For us, we have several competitors that do sort of similar things. Actually fewer now, because some of them got acquired by bigger companies. For example, our competitor in the makeup area, Modiface, was acquired by L'Oreal. What we see is that a kind of a competition that we didn't have 10 years ago is actually the open source community. Right. Because some of the things we do, 10 years ago it was like, oh wow, tracking a face like that is just science fiction. You certainly cannot find an open source doing it. Now you can find some of those tools for free. So we really need to be much better and to answer to specific requirements. When you can get something for free that works okay, then your product can't just be okay.
So the question is it possible for Visage technologies in the future to go open source?
Maybe not open source, but we actually do have a light version of our FaceTrack library that you can use for free.
So people can actually access this?
Yeah.
All right, so after this, I guess a lot of people will try that, hopefully.
Hope so. But then again, if you're, for example, if you want to do driver monitoring or if you don't want to do high quality makeup, it's not good enough if it only works in these angles under these lighting conditions, and that's where we still and for quite some future can do business when you have high requirements.
So Micheal, do you believe in open source? That's a big question that everybody's trying to tackle.
Yeah, I really like open source. We using some, when it's come to artificial intelligence and building models, it's always like, if there is something open, I will use that. But most of the time you have to do it yourself anyway. But we always check, if there's something we can use. But if we go back a little bit to you were talking a little bit about competition also. I think from Norna's side, our big, I have an investor that asked me, "Oh, Michael, what you are doing, Amazon already doing this?" And my answer is probably they do that, but that's part of the core. They will never share this. And of course, the big company, they have really the resources to do this. But I think anyway, that's why they win. They are so good at this, and that's part of the core. So I think there is a big opportunity here to look a little bit what they are doing and do it as good as them, and try to sell that technology. So I think there is opportunity.
You said that Amazon might not share their solutions. Do you think that Norna will do it in the future?
We will not share it like open source, but we give the traditional industry an opportunity to buy the same technology that Amazon have, for example. And I know it's super complicated to develop products, and this big kind of like H&M or the big companies, it's they have the money, but it's complicated to organize a project, to do this kind of technology. So if you're a startup, I think you have a big opportunity to do that.
So let's take a question from the audience, and you're of course welcome to ask any questions. So John says, super interesting and nice talks. Thank you for that. Any suggestion regarding how we can improve the collaboration and funding for innovative startups, scale-ups, and systematic innovation business models? This question is general for both of you. So any suggestion regarding how we can improve the collaboration and the funding for innovative startups?
Oh, I really wish I had a really good answer to that, because that's a good question. Yeah, and also I would really wish for it, because I'm involved in a few startups as well, and since I'm also part-time at the university, and it's relatively easy to get project money for a company collaborating with a university, but then typically the university gets the money and the company is supposed to be the co-founder, which if you're a startup with no money, you can't really do that, and that means that, okay, to get the money you have to go back to the university, and then there won't be a startup, and I think that's tricky.
I know that feeling. I'm also at the university, and it's tricky there. So Micheal, do you have any comments on that? So any suggestions regarding how we can improve the collaboration?
Yeah, I've been doing so much startup over the years now. It's super hard to get funding. I know that. It's like, oh my God, in Sweden. So my suggestion is and it's even if you have super interesting technology, it's even harder because always it's a little bit complicated. It's difficult to understand. It's an innovation. So my strategy is always, to, if you have super interesting stuff, hook up with the big tech companies like Google or IBM or Microsoft, because then you have like a much bigger like platform, and it's much easier if you to go outside Sweden, because the big money is outside Sweden. If you got like financing companies or VC companies or investors, it's much more money out there. So for me, it's always been like that way, to find the right partners and find like external funding from other countries, because in Sweden it's a small market.
So do you think that Visage Technologies and Norna could do some collaboration in the future? Like, for example, face tracking when people are shopping, or trying to figure out when they are going to choose a different color or a different sweater and so on at the store.
I think that maybe if we would be in the same project, I think there would be a third partner needed, like the real problem owner, because I think that the large retail chains, for example, they would like to do that, and they will probably need both our kinds of technology, but they would also need probably to be in the middle.
So who would be this middle part here? Is it a big company like, let's say, a famous brand?
It could even be the retailers. I mean, some retail chains, they have their own R&D, and I mean, Walmart was pretty early in checking how they could do these things, and I don't know if that ever led to anything, but probably something like that. Because you need the entire picture from the well, end user, may be the wrong word here, but the shops, and we would not go into there because we would like to specialize in our technology and so on. And I suspect it's the same for Micheal. So I think a third partner would be needed, and then I think that such a consortium would be a good thing for investment or for actual funding from European money or whatever.
It's interesting what you're saying about big brands doing it as well, because people tend to believe that research only happens at the university, but the big branding companies are sometimes way ahead of, let's say, the target example of predicting what people want to buy or going to buy and advertising correctly. So the companies are also doing a lot of interesting research. So if we I have a question for Micheal here, and would the chatbot be interesting or useful for the product you have at the moment? And if it would be, what would the chatbot help your future customers with, or the user of the application? So would you add different languages, or would it be used for helping understanding the tool or improving the experience, or do you think it would be useful to implement such a conversational?
Yeah, I understand. We're talking a little bit already around that, because we have like an interface for the product right now. And one problem that we have is like we really need feedback from the customer all the time, because we really have to add the real business value for this kind of products. I can see like using this kind of tool just to always detect how they're using the tool, so they can use like a chatbot or something like that, just to give us the feedback for the user experience or what kind of needs they have. So of course, yes.
All right. So the face tracking, could we have we set it up in the background so that we can try it live? Do we have it? So let's give it a demo, and if we could, is somebody using it? All right. While they fix it in the background, we can continue to the next question. And this one is actually for Jörgen Visage here. Are you using the face tracking application or the product somehow to simplify work at the office? For example, check-in and check-outs. When scanning the face, this person is checking in now at 8 a.m.
Well, there are similar things. One of our customers actually use it to so that you can have it on your camera on top of your screen to check your posture for ergonomic reasons.
All right, like now, for example.
Yeah. So it will warn you if you're like, okay, now you're slumping, now you will hurt your back.
All right.
And another customer of ours, they are currently installing the first systems where we enter a factory and it tracks the face and tells a thermal camera where the eyes are to measure the temperature and check if there might possibly be a fever, which has been popular the last month.
It's a good topic at the moment. Yes, that's really relevant. But are you using at Visage at the moment the product to do that?
No, we don't.
Your own internal.
No, we don't do that for at least two reasons. One is that it should be a bit more free with working hours. So the other thing is that, everyone is working from home.
Yeah, exactly. So when if we continue this, when your customers use this product to let's say look at the posture or the temperature in the eyes or the whole body, do you collect this data?
No.
You don't?
No, we do not do that. Partly because that's what our customers do if they want to do it, and also the things we do. We do things that are executed on the local machine. It should be you shouldn't need a supercomputer on the other side of the internet.
Yeah.
So most of the things we do are designed so that you should not need to transmit any personal data. So that you can build your systems, without sending GDPR
that's true.
non-compliant data to some server in the US.
Especially US.
Yeah.
Micheal, how are your views of AI transforming so many industries? I mean, you're pro, I would say, but do you have any thoughts on where it could be bad?
Yeah. I have an example here in China, for example, that to tracking people, it's really, really scary. And my feeling is also using like AI that Facebook and the social media using it's also like super scary. So I think there is some areas that it's a lot of areas that I think it's really, really scary. And the sad story is like all these big tech companies using all this data to optimize, the products. And for example, I have a background in medtech. I know how super hard it is to find the data. And when we're doing like medtech, we're doing it for like good things, to solve the real health problems. So and that's, so my view right now, it's so difficult to do like medtech project using AI. So I will not do that, right now anyway. So that's my view.
And do you think that how do you think people will react AI taking over so many jobs that the human contact is important to have? For example, it's sometimes I would like to use the self-checkout in the stores, but sometimes I actually want to have contact with another person because it feels more, maybe I'm happy that they are even more, in need of human contact. Do you think that is the world going towards more, machines and AI and robots? How do you think that will look like? And do you have any comments on that specific?
Well, maybe it's rather that people switch to online shopping, and when online shopping gives a better and better experience. For example, using our technology so that you can, and then not only for the face, but you can actually see the products. You can have virtual try-on of clothes as well. There are some very interesting companies on that. But when you actually go to a store, a physical store, then it's probably because you want to discuss with a real human. You want to have these. You want to have that kind of service, which means also that the stores will probably be better and better on that because.
The SDK you're
No, I mean the stores will be the physical stores will be the real reason to exist for a physical store will be the human service. Stores where you just would go just buy something and not talk to anyone, why would they be there at all? So the stores will, the physical stores, then they will probably transform to actually have better and more human, real physical service.
I really hope it becomes like that and not everything goes online, because sometimes it's nice to just be outside and actually do some shopping and not just sit at home and do the shopping, because like you said, the experience becomes much better if these products are applied that simplify my experience, let's say, while I'm at the store with the human contact as well. So it's a combination of all three.
While some things you just buy by bulk, you're not interested in, you just want to check, and so we can remove physical stores for that.
So what about virtual shoppers? Do you think that let's say if you have a store where there are displays everywhere, and I think I've heard a scenario where you can have a virtual shopper following you on different displays when you are shopping, and they interact with you. Do you think that is something the future is going towards?
Well, that depends on what people actually would like, how they would like to have, and I think that's, there will be a winding path to whatever it will end up be, and the technology will be there, but what will people actually like, and what will people actually be prepared to pay for in one way or another? That's Micheal maybe can answer that.
Do you have any comments, Micheal?
No, I don't really have any comments on that. No, I think everything is it's about the user experience, and I think there will be maybe some stores that will have that concept, and I also think that there will be concept that people want to have a good user experience. So I think it's going to be a mishmash between technology and human people.
I know that there was this exhibition that you could get a personalized fish following you on the display on the floor. And that was so cool to hear that you when you entered the museum, you got your own fish that followed you. That sounds so cool. I don't know exactly where, but it was a couple of years ago I heard about that. It was at the university. Some did a master or a PhD even. I don't know exactly what. So Micheal, the algorithms you have implemented, do they take the environmentally friendly factor into account?
Yeah, that's true.
They do.
Yeah, I think that's a big movement right now, especially in the fashion industry, to look at that. So we're collecting that data also to understand, what kind of material they're using and where, for example, the manufacturing, for example, to understand that a little bit more, because some of these brands, for them, it's super important to do that. So
it's looking for the.
No, when it's come to this kind, it's mostly we're using the NLP because it's very difficult just using images to understand the materials, for example. So we just if the vendor is writing out that we're using this kind of eco-friendly material, then we tag that, okay, eco-friendly material, so we can so they can look at that also. So it's not super advanced.
Mm-hmm. I have a question for Visage. If we continue a little bit on the tracking part here with people, do you think it can be used to track lost people? Let's say a child at the mall, because that has happened to me, and that's actually really scary.
Yes, if you would then go to someone and say, "Oh, I lost my kid," and I have a photo of that kid here.
All right, so you have to have a photo.
Yeah, I
to
mean,
show
we because technologies like ours can track, but I mean, it can't tell that it's your kid if you don't tell how your kid, what your kid look like. It could, then of course, the tracking technologies could be used to localize all kids in the store, and.
But how far are we away from where they show in movies where you can track people live in the video streams, CCTVs and so on? How far are we away from that?
Well, the technology is there, sort of, but it's not applied because it's not that you have good quality digital cameras everywhere, except maybe in certain places. And they are usually not used. Well, maybe these new systems in China is a contradiction to that, but just because there are surveillance cameras everywhere doesn't mean that you can actually track faces everywhere. A lot of them are low resolution, bad angles, so some of these things can be easily done, and some of these things we are really far.
We still need to, get better equipment.
Probably we don't want it everywhere either. So
exactly, that's a question we are going to get into soon. So if we talk a little bit more about the data, so you both have talked that you have a lot of data, you scrape the data and so on. Sometimes you can buy data from other companies, but where do you scrape the data and for training these algorithms? Let's start, for example, with Visage.
Well, it's different because some data sets you can buy, as you said. There are we also do academic research. I mean, two of my colleagues are PhD students, and we publish papers, and there are a lot of data sets available. We also, and that's actually the topic of one of these PhD students, to improve the data sets. And then we also collect our own.
All right, so you ask people to volunteer.
Yeah. And then we have students who are getting some extra money by sitting there annotating the data, click on the feature points and so on. So it's sort of a collection of buying, using freely available, and also creating our own data sets.
All right, that's good. And Micheal, where do you scrape the data from?
Yeah, so we're doing actually the same thing because so we try to use like free data sets if there are, but most of the time we can't find them. So sometimes we have students helping us creating the data sets and do the annotation, and we're also buying these kind of services there is a couple of companies, I think in the US, helping you out. So if you have like 100,000 images, they can help you do the annotation. So we buy that also, that kind of resources.
And I think that answers the second question we have from the audience. When is scraping data legal or allowed, and when is it not? So, for example, from fashion websites, and I think we both have covered that. You can either buy or collect your own data, because nowadays everybody needs to, hold on to that data or sell it somehow. So if we continue to, how often do you have to train these models with new data sets?
Well, our data sets, they are continuously improved. So, and then, well, the algorithms are as well. So it's like retrained all the time.
All the time.
Yeah.
And Micheal, do you have any?
It's an ongoing work all the time, to do like more and more training on these models. It's always like some kind of drifting or stuff like that. So we have to train them all the time.
All right. And there's always, challenges with data. It never comes clean. That's one of the biggest, or one of the biggest issues. Yeah. How does the algorithms for Visage deal with the issue of bias in the training data? For example, unbalanced images of females versus male, or racial, or how do you find the balance in the data so that it doesn't become biased towards one direction?
Male, female, for example. I mean, we would like our tracking algorithms to work for both, obviously, and also for then. Fortunately, we also have the classifier for that, so we can actually check the data, and then it's maybe it's the most tricky for facial expressions, because how do you get real training data for real facial expressions? Well, that's quite kind of easy if we talk about happiness. I mean, tell a funny story so that people, whatever. But how do you get, in an ethical way, the facial expressions like fear and disgust? I mean, you don't want to do that.
You don't want to test that. No.
So then it's actors.
Right.
So it's which means that we actually do train on fake data. I mean, it's acted expressions, and then okay, we're hoping that the actors are good.
So is this real actors or is it students?
No, that's typically real actors. Maybe we should film them when they get their exams back and fake. No.
Yeah, no, not that feeling. That's a horrible feeling. So how soon do you think these smart dressing rooms and the makeup mirrors will become common here in Sweden? Or are they common already?
No, they are not common, but well, they will start appear in shops, and you can now, if you go to trade fairs, you can see bathroom mirrors where you have these kind of things built in, but there will be another few years before they are like readily available. I mean, you can find them but you need to be very specialized.
Right. Do we have the demo up and running? So maybe next time. And so let's talk a little bit about privacy. How has the GDPR regulations changed the way you operate, both of you? It's a question that is often asked. So Micheal, should we start with Micheal maybe?
Yeah. In the case of Norna, it's quite easy because we're just using like external data. But I'm working in the medtech before, and I know it's a hell, to handle all this GDPR. It's costing a lot of money. But on the other hand, I think it was quite nice to have some rules to handle, all the data, and just knowing how to use the data. So I think that there is a positive way, to look at it. But as a developer, it's like always super hard to handle it.
Yeah. Well, for us, it's actually a competitive advantage. Since our software is used to, the typical usage is that you actually have the processing locally and do not transmit it. So for example, Microsoft offers some of the things that we offer, but then it's the computations are done on their server, so you have to transmit the images there, and well, that's can in certain cases be less compliant with GDPR. So that's one of our selling arguments. With our systems, you can actually, with our technology, you can make your systems GDPR compliant and not let the personal data run away.
All right, that's very interesting. And if anyone from the audience wants to ask any questions, we are open to receive any, and or if anyone from here actually wants to ask anything. All right, then we are almost out of time, and just a few things to wrap up. We have learned a lot about how these facial tracking works and how Norna does the prediction and trends and so on, and we have had some nice discussions here. So if somebody is interested in taking this path, what is what has helped you to get where you are, and what advice would you give to other people?
Well, I've been doing what I'm doing because I like the technology. I mean, I'm a tech geek, and nowadays I know that a lot of people see me as the entrepreneur and businessman and stuff, but that's like a side effect. I've been fascinated by these things, and I'm really enjoying working with other people with those interests. And the gang that I'm working with now is well, they do the implementations now, and they do the algorithms, and they tell me about what they're doing, and sometimes I might even maybe have some intelligent comment, but now it's more fascinating to be part of it, and that's.
So do whatever you find really, really nice to do and enjoy to do.
Don't do this because dig into this just because this is a buzzword. I can probably make money somewhere.
That usually never works.
Well, and even if it does work, how fun is that?
Yeah, I mean, we recently had our IEEE visualization conference. It was last week, and people say that they just add AI to everything because AI is such a hot topic, and this was really, really true this year because there was a lot of papers that used AI for really unnecessary stuff. So do something that you actually want to do, and not just because it's cool that other people do. That's really good. Do you have anything to add, Micheal?
Yeah, I think from my point of view, in the old days, I really like technologies. I really want to start with the technology, but I think over the years, it's more like, what kind of business value can we add? And I've seen, like in Norna here, I try to avoid AI all the time. If we can solve it in another way, that's good. so try to do it as simple as possible. But I think just, I have an idea about the business value before, and I haven't done that all the time. But if people can do that, I think they're gonna save a lot of time and save a lot of money.
That's good. That's good. So if people are interested in contacting you, where can they contact you the easiest? I know that you showed your email and so on, but let's say they want to, can they add you guys on LinkedIn and maybe email you if they are interested in going deeper into this? Where else can they find you?
Yeah, both those things work. I'm a bit swamped by emails, so sometimes there are reply times and if you contact me by LinkedIn, write some explanation why you're doing it, because if I just get an empty request, then okay, who's that? And I probably forget about it.
So it was a good thing I actually did add some note when I contacted
you.
Yeah. All right. See, it actually works. So please, if you enjoyed this talk and the panel session, give it a thumbs up, and follow us on YouTube, LinkedIn to help us improve for future events. And this was our first ever virtual event, and we hope that it actually went through. So Micheal, do you have any other ways we can contact you? Because people like to get contacted so much.
Yeah, I think if you can contact me through LinkedIn, I think that's the best way. So just send me like a message through LinkedIn, and we can hook up there from. I can give them my email address there.
All right, that's good.
Yeah.
All right. So, and one last thing, we would like to thank Norrköping Science Park for helping us set up all this event and being here at Coffees. Thank you very much, and good night.